I will add more real-time use cases questions.
Okay,
Um,
so
yeah.
I've not been able to do the installation. Why? Because I have a message on my, like the message I sent you the last time, the one I answered, that I said it looks good. So I had some couple of questions, like two different ones, which I have answered, and they've asked me, they sent me a link for Teams Microsoft link to schedule time for the intersection interview with them. So I was putting after the class, I will send it to you. So I just
Okay.
finished them yesterday, and when I sent it to them yesterday, it was late on your side. I would have sent it to you to review, but when I sent it to them, they get back to me and send me a message that I should create a link for us to have a conversation for the interview. So that's what I've been battling on. I said I will let you know after this section today.
Okay. Sure.
Hello? Can you hear me, sir?
Yes. Yes.
Yes, so that's the reason why I've not been able to do the installation.
Okay. No issues. Evan, you can try on the AWS EC2 instance as well if you're not able to do on the local machine. You have a Mac OS?
Windows.
Windows. Okay. No issues.
गरीब लोग है सर.
Mhm. I think mostly use Mac OS there, na? Okay. Anyways.
No sir, the thing is that poor peoples are using a Windows only. Rich peoples are using a Mac OS. Right,
Mac
Naben?
OS, yes. Don't worry, when we grow up, we'll get it.
Definitely. So we have a two, we can try two things now. Once we will definitely see this project, like how we can set up custom VPC and the EKS cluster through the Terraform code. Okay. Helm chart I will cover next week, which is the part of the Kubernetes. So first, before starting Helm chart, we can start with the architecture, then the autoscale, which Ganesh last time asked question, right? How we can autoscale the node, that we will cover, and then other components and the architecture design for the Kubernetes, and then we will try to create it through the. Definitely, we will try to create the Kubernetes cluster today, but the theoretical concept like architecture and remaining part services and other components we will see in the next Saturday. So going forward, we will move that. So now we have a two, three point of view here. One is like how to create the cluster, basically the question. So first thing we can definitely create through this console base. Okay, EKS cluster. Then second thing is like yesterday I have shared one link, right? Kubernetes, let me check. So you guys are comfortable with this Git now, like creating the branch and adding the content over there.
Yes, very well.
Okay. Because this is how the process you need to work in the real time. You cannot say like, definitely client IDE tool will be like your Visual Studio or any other tools, IntelliJ something. But somehow like whatever the codes you are writing here, that should be in the GitHub branch. So that the real time use cases. The second way we will see how to create the cluster like through the command line activities, which is the EKSCTL. Anyone try to install that EKSCTL?
EKS no.
Okay, you can definitely try. So I think AWS CLI and access management you already configured on your local machine last time. So now just only additional step is required to install this EKS I have added the detailed link here. This one. Install kubectl. Install kubectl and then your EKS-CTL. EKS-CTL is just to create the Kubernetes cluster through the command line. If I show you the command, how to create that, so you will get the idea. This is EKS-CTL create cluster and like this command line. And how much worker node you require, you can just pass this number. So I will quickly show you through the command line because I have already set up this all the things like the prerequisite is like first create your IAM user with admin access, then generate access key and secret key, which you already done. Install AWS CLI, which is also already completed, right? Then only two things you need to get now, like install this kubectl command to run the to access the Kubernetes cluster and the perform the commands, right? Kubectl get node, get pod like that. Then your EKSCTL to create the clusters. Okay. Please just install these two pending tools on your local machine. Then you will be ready to create this cluster, Kubernetes cluster. All the process I have already mentioned here step by step, but you can just skip this because you already done. You can directly jump to install kubectl. Okay, I have already given the link here. You can just simply visit that, download or just install this through the curl command. Okay, directly. Once installed, you can check by using this kubectl version. Let me try on my local machine. Let me open the command prompt. Okay. Okay, on the command prompt, it's working here, client version. Then next, you can just visit this website, download this EKSCTL package. I have given the name with the screenshot as well. Okay, so you should not worry about that. Just for the Windows, yes, this package you can easily download. Okay, once the zip file get download, so same thing like what you have done for the Terraform, same thing you can just unzip it. Okay, and just copy that EKSCTL to your C drive. Where C drive, for example, if you are using Windows C drive, then your users, sorry, not users, program files, and here EKSCTL, create this folder EKSCTL, and you can just paste that application here. Okay, and same thing for how to set up the environment variables on the Windows machine. From the control panel, then open this system, advanced system setting, then environment variables, same process like what we have done for the Terraform. Path, just click on edit and then just add that EKSCTL prompt here, URL, and just save it. Once that is done, okay, then you can just simply just execute this command to create the Kubernetes cluster. So if I try directly, because I have already set up, so you can definitely just missing step, you can just follow. If I try here, it's a bit okay. It gets additional step space, so he just directly executed. If I mention here, basically you can just mention the Kubernetes cluster name, then your cluster version 1.29, which is the latest, then your region code app south 1, node group, you can give the node group name here, and whatever the instance type you want to create, like T3 medium or something. So based on that, you can just mention, and how much node you need required, you can just mention here. Okay. If I just copy, let me check that. I think he already started because he just press enter automatically. Anyways, we can see, go to the AWS console and just check the status. In Mumbai region. Yeah, it's creating, and you can see the version 1.29. So it will take around 2 minutes, I think 5 to 10 minutes to get it ready. So let's wait for that. If you are using any older version like 1.26, 1.28 something, so you will see the icon here, upgrade now. Okay. So on that, you can just upgrade it. So meantime, what we can do is, let's try to understand that Terraform code. This is the one of the steps. Okay. Second, when is like manually, how you can create cluster. Go to AWS Service Console, just search EKS Kubernetes service. Let me open in the new tab. And here just click on the add cluster and create it. Okay. So you can give the cluster name here. Let's say demo cluster, but you can give the name like manually. Okay. Or manual. You can choose the version. I think they have released latest one, and they have different support model. The 1.28 support model will end on the 26 November 2025, and this 26, and this one also 26. Okay. Okay, we can keep default one anyways. And here cluster role we required. If you don't have created the cluster role, you can just simply go your IAM user, IAM. Not user, here in this case role only. Okay. If I search this role just to check what permission we required, because by default in your case, if you don't have any role already created, service role, so you have to create new one. Okay. For this I have already created because this command line process is going on, right? So that's the reason he automatically created. But through the manual, we need to create manually. Okay. So if you want to verify what permission are required for this role for the cluster management, so we can see EKS demo cluster. So let's find out here under the IAM user service roles. Okay. Let's say demo EKS this one, right? If I open it, this is basically the cluster policy management. EKS cluster policy management. If I expand it to check the permission, you can see auto scaling, create route, auto volume, create volume tags, describe, modify. So basically load balancing, basically to manage the cluster in the node group. Okay. And the second policy is EKS VPC resource controller. If you want to create manually, for example, in your case, just click on this create role. Under service use cases, you should select here. In our case, what will be the use case? EKS, right? Not the EC2. EKS, then EKS cluster, and just next. And you can give this permission. Okay, EKS cluster policy and the second policy as well, which is the VPC resource controller. So you can just assign that and you can give the role name, whatever the role name you want to keep, like demo, EKS role. Okay, and just create role. Okay, and once a role is created, you can just refresh from here and that role will pop up here. Okay, so I just ignore that steps, but you can just follow that, right? So now the next step is like alloc cluster administrator access. Then I will go with the default one. Encryption not required now. Just next. VPC, which VPC you want to use? Just select that. In my case, let's say ND VPC, which I normally use for the practice. Then your subnets, security groups. If you want to create new ones, you can create or attach existing one. And cluster endpoint. The cluster endpoint is accessible from outside of your VPC. Worker node traffic to endpoint will stay within the VPC. Okay, public or private we can keep by default. Next, send Prometheus metrics to Amazon managed service. So this one I have not tried, but normally in last project where when we work, so there was a fluentd. So whatever the pod we are deploying in the Kubernetes cluster, so we send all the logs, pod logs to the Kubernetes dashboard or the Grafana something. So, but with that in that case, we use fluentd there. Anyone heard about this?
Yes, for that, whenever we are doing this in the just like a physical installation, on that
Hmm.
time, Fluently also required there. This packet is also required.
On-prem.
Yes.
Okay. So for now, I'm just skipping the logging part. So I can just simply go it. And just, I will keep the default one. And just next. So it will take a little bit time. So now we have a two cluster. One is created through the AWS CLI, EKS and one is for the manual. Okay. So this is this manual cluster once created that we need to perform one more task here. Then we need to create the node group here. Okay, this is the manual process, but which we have executed through the command line. So this one, right? It's an active state. So let's get that. So we can see the endpoint and the other details here. If you click on the compute part, so let me refresh. Let's go to the EC2 and check the status. We have mentioned 2 nodes, but still he is not created. Okay, if I try to add manually, ideally it should created. I will check later why he's not created. Node I am a role not found. Okay. Let me create the node I am a role here. Okay. Now coming to this I am a service back, create role here. Now this time use case will be EC2, okay? Because we are configuring it for the node group. Then click next. Now in this policy, let me check quickly. There are 2-3 policy we need to give. Anyone tried before creating the cluster through the console or any other method for practice purpose or any in real time?
No.
Okay. So here we have a 3 policy we need to give. Amazon EC2 container registry. Read only. Then another policy is like Amazon EKS worker node policy. Okay. I will send you the detailed steps, so don't worry about the manual process. Amazon ENI EKS CNI policy. Okay. And just next, we can give the name role like the demo EKS IAM role node. For example, let me copy this name, create. Maybe he doesn't find role, so that's why he's not able to create the node here. Might be. But last time when I do the practicals, so he was created properly. So now if I refresh it, okay, I can see now node standard worker group node desired size 2. If I verify from here, let's see. Okay, it might take a little bit time, I guess. So now we can see there are 2 worker node already created. It's an initialize process. So now if we want to access this cluster from our local machine, what we can do is that configuration file we need to update in our local machine. Okay. So there is one command. So let me type that command here. So for that, that kubectl and ekctl for required, which is the mandatory command line utility to get it created from your local machine. Okay. The command is like AWS EKS update config, sorry, kube config hyphen your cluster name. Okay. What is the cluster name? We have given demo cluster, right? Which is the command line we created. demo cluster, demo hyphen cluster. So required token and access key is it will add in our local machine. Okay, you can see whatever the API endpoint which is required for the master server. So that will be updated in our local machine. So we can connect that API servers in the Kubernetes. So from there we can access our node and we can do the deployment of the YAML files for pod services like that. Okay, so going forward we will see that. But for the today session we will only see how to create the cluster. So where it's stored the context that's stored under the user name dot cube config. Okay, so let's verify. If you have multiple Kubernetes clusters, you need to switch the context. Otherwise, how it will identify like which you are whatever the command you are executing, that how he can identify like where that command need to execute, right? API server users name kube config. What was the path? Okay, dot cube and then config dot cube and then config. Okay. If I try to open this file, okay, so all the certificate authority, your cluster details, this is the ARN of the cluster, right? So this is, as of now, we are only using single cluster. This was the earlier cluster, which I had done the practicals, okay, today morning. So you can ignore that, but this is the another one cluster, which we created manually through the command line, no, demo cluster. All the details it will store automatically. So then if I try to execute the command now, let's say kubectl get nodes. Okay, we have a two desired node, right? So we have created two. So that's we can see here. So these are the default namespaces. As of now, we have not created any new namespace where we can integrate the service. Okay, so we will see going forward that. But for today's only, this you can just verify like we have successfully created the cluster with the two node group. You can see the IP address 235 and 237. Okay, if you want to verify that, go to the EC2 section and just check the IP address 237 and 235. Okay. Okay, because we have not created anything now, so we will see. So the demo cluster is fine now. So once we another one we have created manually, right? So here we don't have any node group now. So what you can do is you can just simply create from here, add node group. You can give the node group name like demo node. Node IAM role required, which we already created this one, right? Demo EKS IAM role node. So I will send the that policy name which you can create simply and just create it. So he will ask like Amazon Linux on demand, instance type, disk space size, node group. This is the scaling part, Ganesh. You were asking last time, right? Where we can define that scaling part. So you can just define here what is the desired minimum and maximum you required. So based on the load on the worker node, he will automatically scale.
Okay.
Yeah.
And for RAM utilization and other things there, or what? For example,
We
scaling spots, two types are there. Scaling spots. One, one parts node will be increase. Second part, whatever the RAM size are there, if RAM or CPU utilization is there, so on that basis, RAM or CPU getting increases. Third parts is node additions.
hmm.
If I'm think if anything is wrong from my side, please let me know, because scaling parts I have read that the two three types out there, so that's the reason I'm asking.
Okay, and by of now we like when we work auto scaling parts, so there was option like network base or CPU utilization base. So in this case, let's verify once again. Okay, I will check and come to this tomorrow next one, or I will confirm on the message in WhatsApp. So now let me check the node. So at least now we can just go with this. Okay, default one. Max, set the maximum number of percentage available nodes to be installed, right? Okay. What we can in the percentage. Let's go with this default one. Okay, subnet it's automatically created, which we selected VPC, right? ND VPC. This might also takes little bit time to create the node. If I go back, so we can execute that command one more time. So instead of that, we need to change the cluster name, demo cluster manual. Okay. If you want to verify one more time, so you can see the cluster identification has been added here, demo cluster manual. So now let me check on which, how to switch the context for the cluster. Okay. Okay. So now we have two context now. So let me check how we can select particular one. Okay, let me check. Okay, these are the available context. I mean the number of try create the Kubernetes cluster now that's already stored in the that config file, which you can see practice users, demo cluster like that. These are the manual cluster which we have just added. And this is the earlier one, right? Which we have created through the EKSCTL command line. So now if you want to execute command on particular cluster, so we can set the context like this command, set the context to the cluster you want to interact with particular cluster. We can execute kubectl config and your context name. So let me copy in
Namdev,
the
Namdev, could you
yeah.
repeat this context things?
So basically in real time we might have a different cluster, right? Like for the one application, not application, let's say one project. If you have only single cluster, then you don't need to worry about this context switching. Okay, only if you have a multiple cluster available in your environment for the different projects. So in that case, how that kubectl command line utility will identify, like whatever the, let's say you are executing the command kubectl get nodes. Okay, how that command will identify that command should run on which cluster, EKS cluster. If you have a multiple cluster available in your AWS accounts, for example,
Okay,
if you
understand.
that is only the context switching here. If you have
Means
only single cluster,
whatever the
huh,
namespace are there, cluster is like a namespace, na?
namespace is different thing inside the cluster, which is your isolation part. Like environment wise, you can create the namespace. This is basically as simple as the context means your cluster name. So when you are passing the any commands, first you have to set the context like a cluster on which cluster you want to execute that command.
Okay, understand. Understand.
Yeah. So let me add here, and I just need to replace the context name. So we have already get the context name here by this command. This is just additional things I am just trying to get. If you have a multiple cluster available in your environment. So here I just need to replace the context name. So let's find out namespace, your auth cluster. So which value I need to use? Let me check. Or does it have any information? Okay. Demo, if I want to use demo cluster, for example. Let me set this. Okay, the first line is current, then name, namespace. Let's me try one by one. Yeah. So basically you need to pass this ARN. Okay. Your whatever the cluster you are ARN is available, you can pass. So if I try to execute this command now, kubectl get nodes. Okay. So let's see which nodes he will fetch, and we can cross check. Okay, let me try to update that configure once again, which we have executed last time. AWS EKS update kube config demo cluster. Okay. If I try to execute now, let's see. Okay, it was a 235 to 237, right? Last time we checked. So let me switch now context to different one. So now we are trying to get the context for manual. Okay. And if I try to execute that command, let's see if he is asking to update or not. Okay. He's asking the credentials. So let me update that manual. Okay. kubectl, sorry, EKS update config for manual cluster. Okay. Okay, context updated. If I try to execute now, okay, I will figure this out later. How to switch if we have a multiple cluster, how to context switching we are done properly, but when we are trying to execute that commands in that particular cluster, we are getting issue. Okay, for single cluster we are fine with this. Okay, I was just trying for the multiple cluster, but for the single cluster, is anyone any doubt?
Multiple doubts are there, but we need to, I think, revise one time. So after that, we can get some idea about this.
Yeah, sure.
For me, it's kind of complex though, but I will just have to watch the video over and over again, then I can take it out.
Bro, same thing here.
See, what we can do is next Saturday, I will not take any session. So you guys can show me like how you are executing the Terraform code, and then you can just ready with this configuration like EKSCTL and your kubectl. Okay. So I have already given the steps here how to install on your local machine. So next Saturday we will take only those your complete setup. Okay. We will not go further on that Saturday. Is that fine? Because these are the main topic that's you have to make it working on your local machine. So going forward, you will get some confidence on that.
Best things, Namdev. Very, very
Yeah.
best things.
Yeah. So just make sure you can install
Me,
this.
I agree.
Agreed.
Siddhu आणि रोहित, please सांगा.
Yes, we are
Yes,
agree.
I
No
am
issue.
agree. My
Okay.
net
Only
is
at least
very
you should.
low.
Hmm. Sorry. Can you please repeat? I can't hear.
We said we are agree. No issue. We can do next Saturday. Yeah.
Because these are the important thing, na? Terraform and Kubernetes. So at least, so we can try. So just make sure that kubectl and EKSCTL you should install properly on your local machine. That is the only requirement. So once you set up completed, you can just send me the screenshot on our group that you have completed with this setup. Because the AWS CLI and IMA part you already covered last time for the Terraform. Whoever not covered, you can just please cover that, okay? And apart from this, just install kubectl and EKSCTL. It's not a big deal here. It's I have given all the steps here. Okay, once that is done, so let me know so we can Saturday we can just connect and just do these practicals. Let me share this link. So I can understand if someone trying first time, so it's very hard to digest quickly. Okay, so that's what we cannot hurry here. We can go slowly, little bit. And the next part we will see once you are satisfied with this in from your hand, like you are able to run the Terraform code, Kubernetes cluster you are able to create through the EKSCTL manual. Okay, and obviously from the Terraform code, then we will move for the further part like your pod setup, YAML file. We will try two three setup there. Okay, and I have this ready-made setup. I will show you later, not now. Otherwise, you will get more confusion. So I have a EKS cluster setup and where we can install the WordPress pod on the Kubernetes cluster. I will show you that as well. And in that case, I think you already clone this project in on your local machine, right? This one, EKS VPC Helm chart. It's available
From where?
here. The link which I just shared, na? So that repository you will get that project. Deploy WordPress on Kubernetes cluster. So inside that you will
Okay.
get that this project, Terraform and Helm chart. So I'm hoping like this one will not set up on my machine. I will you can just share your screen and I will guide you like how you can do this. So you will get some confidence over there. Only thing like you can just I will show you at that time because in this module based project, this is you can consider as a real time project. So here we are not storing our state file on local machine. Okay, that is the only difference. Here in the backend.tf you can see I have created one S3 bucket, demo, DevOps, Kubernetes, Terraform backend S3 bucket on my account. Okay, you can see here S3 bucket, this one. Okay, this one I'm running just executed for the just to check the output. So that's why you are able to see this folder. But first you have to create the S3 bucket in your account and then you can just replace here. Okay, because same bucket you cannot create as I already created in my account. As we learn, S3 bucket is a unique name, right? So these are the other configurations. So I would suggest till next Thursday or Friday, you can just go through this Terraform code. This is the main configuration file where, and here when we say module based now, so here
Hello,
last
sir.
time we see, yes,
Am I audible properly?
you audible.
So, what is the key in that backend file?
Which one?
In the backend file, key.
This is basically we are storing in the folder structure. If I show here, So in S3 bucket, when you are managing a S3 bucket through the programmatic way, like any from the application code or any things. So wherever whatever the path you are giving for the S3 bucket, that path will automatically get created. So for example, this is the backend S3 bucket. So here he will pass automatically the path. So you can see VPC, under VPC we are storing the state file. So if you open this VPC, you will see this file automatically created. It's 180 byte.
So VPC is a path.
Yeah, VPC will be a main path, like main folder structure. Inside that,
Okay.
we are storing this state file,
Okay. Okay.
and bucket parameter you can pass for the bucket name. So last time we have seen we are created the EC2 instance, your load balancer, S3 bucket, right? So everything will available on the was present on the same file, right? Main.tf. So in this project, we are separating each thing like in the module base. Like your providers will be separate here, AWS provider. Then your subnets will be in the separate file. Okay. This is only part for the VPC, not the cluster. Okay. Cluster file will be separate. So all the variables and elements available here. And then where we are storing the actual value of this VPC subnets, we are storing that file in the data in the Terraform.tf Okay. So we can use this file tf to store the variable values. So we have passed this CIDR range value, then your VPC name, POC VPC. Okay. And these are the value for the subnets. So in this project, we are going to create 3 public subnets, 3 private subnet. Okay. And you can see the availability zone code. US West. This is for the North Virginia. US East 1A, US East 1B and 1C. If you want to try this for Mumbai region or any other region, so you have to just replace the region code here. Okay. Remaining stuff you can keep as it is. If you want to change the CIDR range, like if you don't want to create 10 dot series, so you can go with the 19 to 160 series. That as well. It's up to you. Okay. And you have to mention the region code here, whatever the region you are going to use. In the variables, you can just get the variable name here. Okay. Values will be passed from the TF vars. Okay. So I would suggest first, definitely I will explain when we try to deploy next time, but at least you have a next 5 days. So just go through and try to understand. This is for the VPC. Okay. And output.tf file will be when we execute this all the command like keeps Terraform plan and then apply. Then whatever the VPC will create subnets route 53, sorry, not route 53, internet gateway. So all it will generate one ID, right? Like the VPC ID, subnet ID, like that. So all the information will print as output here. So whatever the output you require, you can just mention in the output.tf file. So sometimes, for example, we are deploying the EC2 instance load balancer. So if we don't have AWS account access, in that case, we can add the output there for the load balancer endpoint. So whenever the deployment happen, so we will automatically get the load balancer endpoint in the output prompt here message. Or if you are managing through deploying through the CI/CD pipeline, so in that build deploy stage, you will get in the console log that output.
So this is the best practice for that. Whatever the .terraform file is there in the VPC,
Yes, sir.
that is the best practice.
This is based on the one of the scenarios where we got the assignment for the real time. So that for that we created this project.
Okay.
Yeah. This is for the VPC and this separate file for the your EKS cluster where the now when we try to execute this project. Okay. So as we know, we cannot directly create the EKS cluster, right? So that first we required VPC. So that's why first don't execute this EKS cluster first. Okay. Otherwise it will create in the default. First we have to create this VPC up. Terraform
Namdev,
apply in this
Namdev,
VPC.
Namdev, just 1 second.
Yeah.
Just open the VPC. Okay, variables is whatever the variables is there. Whatever the variables is there, the variables are there. Last, yes, whatever the variables are there, it will be available in this folder. Whatever the tf.was in the
This is the actual
tf.was
value.
actual value.
Yeah.
So authentication is there in tf.was.
Not authentication. It's means whatever the variables you are passing here, na. So that actual value we are storing in the TF-vars.
In the variables, whatever the values are there, it
In
will be
TF-vars.
confusing. Was
So let me try to just get it here. So if you don't pass any values in the TF-vars, let's say you have not created, then he will take these default values. Okay. If I open these files in separate tab, let me check. This is the VPC name for VPC. Okay. Public subnet zone, public CIDR, and your private subnet zone. Okay. If I show you here, you can see the variable name passing here, private subnet zone, type list string. So whatever the in the list string we are passing here, it will take as a input value from there. And if you don't pass anything, so he will take as a default value this one.
Just 1 second. If anyone is understanding this, because I didn't got it, these things. Anyone? Rohit, Sidhu, Pratik bhai, or Ben bhai?
No, from me also. I haven't got it. As Ganesh is saying.
Okay. So basically in variables, we are passing this variable name here. Okay. And if you don't want to use TF-var files, we can pass this default value here. Okay. If we created the TF-vars,
Means what you are saying like that. The variables in the variables, whatever the variables are there, it will be available. But means just like a default variables link like that only.
if you don't have values available in this TF-vars, he will consider as this default value. So by default,
No,
it will try to take from the
actual value is available in TF-vars only.
yes. Whatever the value we need to pass, that value should be here in TF-vars. If this variables not found any values, then he will take by default from these values as a default option. So what we can do is in the next Saturday, we will try to remove this TF-var files, and without TF-var files, we can try to deploy this. Okay. And let's see
And
how this works.
and
Yeah.
what about this subnet .tf file? That whatever the subnetting is there, it will be available in that VPC subnetting.
You can see here, not any values available here, right? Only the variables are used here. You cannot find any values. So we are taking from the variable as an input. Where you can see here, let's say, for example, public subnet, where dot public CIDR. Okay. If I open this TF-vars, you can see public CIDR. Where dot public CIDR. And then whatever the counts are there, that will be he will take. So whatever the counts we are passing in the string here, that will take here public CIDR. Same for the private CIDR and private subnet zone. This is for the private subnet. Where dot private CIDR and count dot index. Whatever the count are there in the string, that way he will take as input.
एवढी मगजमारी करण्यापेक्षा डायरेक्टली याच्यामध्येच दिलं असतं ना सगळं उलट बरं पडलं असतं तेवढं हे पण ते पण ते पण ते पण ते पण हा सर
Yeah, but in
म्हणजे
the real
as per
time, you can use for multiple resources in the real time. So you don't need to hard code it in the like a main.tf file we have done last time.
Okay, so how do I install this EKS VPC-HEMS.master on my
So
Visual
we will
Studio?
cover this one more time in the next Saturday, and we will go step by step. So we will make more clear on that. So on the EKSCTL, you have this. You will find this link here. On this cluster setup, this link, you have this EKSCTL link here. There it is.
Oh, okay.
The here one. Install EKSCTL and install kubectl.
It will automatically go to my Visual Studio.
Sorry.
I said once I install it, it will automatically update on my Visual Studio. Is that what you're saying?
You can try from your command prompt. This one.
Okay.
This kubectl and EKSCTL. These two things you need to install.
Okay.
Okay, so we will connect next Saturday and we will repeat this session one more time. Just for from your side, you can just install these two tools. Okay, so we can repeat one more time.
Okay.
Yeah. Any other things apart from this?
Namdev, could you please open that can you share your screen and open that Visual Studio for the Terraform?
Yeah. Is it visible?
Terraform, sorry, Visual Studio. Okay, open the VPC. In that Terraform file is there.
Yeah,
Terraform
this.
file. Yes, dot Terraform first file below the VPC. Okay, this files is whatever the providers are there. On that details, it will be providing these files or license details. No, what available in the .tf files?
.tf file.
No, Terraform file. Terraform files. Yes, it will be by defaultly created.
Once we initialize through the Terraform command, then he will create.
Means whenever we are pressing the Terraform init command, after that this Terraform file is getting created. And what about the Terraform.log in this file? Sorry, I'll be repeating my words. Terraform file Terraform files, when we are pressing the Terraform init command, that time it will be getting created.
Yeah.
Right. After that, what about the terraform.log.hcl? This files it's using for the log purpose.
When you are executing the Terraform,
whenever the users are single user can run this commands.
Yeah, the single process should run at a time. No one can override it. Yes.
Okay. And for example, in our you, me, and Rohit is or Ben is, we are four peoples are there. We have four peoples are working in the different locations. Okay, but we don't know we are working on the same things. So how we can give this type of access to the persons for this Terraform.log is getting created, or else real time environment how it will be works? Could you please suggest
Okay.
that?
Yeah, actually, this could not happen in the real time. Let's say we have 2, 3 team members in our DevOps team. So whenever you are working on something like you are creating any resources through the Terraform in AWS, for example, in AWS. So in that case, you have to create one Jira ticket, and apart from whatever the naming convention you follow, so based on that, you can create the branch from the master branch in a GitHub repository. Okay, then whatever the code changes you are doing, that will be in your whichever the branch you are using. If another team member want to create any other stuffs for same branch, then he need to whatever the things you have updated, you have to push it on your remote branch. Whatever the changes you have done, then he that another team members need to take a pull latest pull on his local machine. So there should not be any changes in the resource configuration in a branch, whatever the Terraform code you are writing. And we both should not deploy at a time, and that is not a best practice. First team member whoever the working, he should complete his task. Okay, then he can just execute his deployment. Both should not run at a time deployment process.
Understand.
So that means we're going to execute based on the prioritize task, right?
So let's say your this is your branch you are working. Okay, and you have one more colleague. So ideally, this should not be a case in the real time. No one, sorry, both teams should not deploy or trigger the pipeline at the same time. Okay, this is not a good practice. So first, whatever the team lead or your one of the DevOps engineer are working on the particular branch, so he can whatever the changes he's doing, he can just push his local changes to remote branch. Okay, if anything want to change in that by this another your team member, if you are on the leave, so in that case, he first should take git pull from the remote branch to his local branch. Okay, for example, you are working on branch 1, so he can just take a clone of that repository on his local machine. Then he can take a git pull to take the latest changes from your whatever your another team member push on the remote branch. If you have not take git pull and you started changing on the same branch, he cannot push directly. He will get the issue like remote rejection something by adding the message like first take a git pull, then push your changes like that. And Terraform by default are not allowed to trigger the multiple deployments at the same time, as you have seen. Also, last time, yesterday we have seen, right? He will create the automatically log file. So during the Terraform apply, he will log the state. Okay, so we will next Saturday we will go step by step. So I will try to explain each files and what is the things we have mentioned here. Okay, so you will get more idea on that. Any other thing apart from this for now?
Namdev, could you please provide us one of the good videos for the Terraform?
Yeah, I will provide. Yes.
From the basic understandings to till top bottom तक वो अगर
Yes, yes.
you are providing that na, so it will be good for us also. So after that we are getting multiple ideas about the video.